Thanks for joining. This is the Tango's KubeNet session on Thursday, the 23rd of January. So we'll do today a follow-up by Marcus based on the, let's say, more the practical side of SDC. And then if we have time, we would like to discuss a little bit the transaction design that we have in mind. And it would be good to get some feedback. Plus also, I think it will do some replace operations then that you were discussing last time. So, but yeah, Marcus, if you don't mind, you can take it away.
Yeah, sharing my screen. Okay.
Yep.
So yeah, last time just quickly showing the slides from last time once again. Last time we've taken a look at the structure, at the CRDs that SDC ships with, that we need to populate to make SDC work, right? So to the left, we've had the secret schema, target connection profile, target sync profile. These all were consumed by the discovery rule, creating a target, which is also referencing these. And with the target, we're able to define configuration per targets, configuration sets, and also retrieve running configuration and unmanaged configuration. So that just as a reminder, with this, I think let's start. So what we have in our docs, which you will find at docs.sdcio.dev, is documentation on the whole project. Today we are gonna take a look at the getting started, where we have a basic usage how-to, which starts with the basics, installing a kind cluster, setting up container lab, setting up the infrastructure, so manager, installing SDCIO, and then all the way down. In this case, we'd be using SR Linux as a box. Today, what I've prepared for you is a use case with Arista CEOS, so that that'll probably suit you quite well, Dan, right? So yeah, with that, let's have a look. First of all, install kind, right? So kind is the Kubernetes installer for usually used for demo and development purposes. I already have kind installed, so I'm skipping that step. Next thing we do is to create a Kubernetes cluster, and also for a later step we will deploy a topology via container lab. And for the cluster to be able to communicate with that lab, we need to set up an IP tables rule or firewall rule. That I've also done, so I'm just going to set up the kind cluster. This will now pull, like in your case, probably pull images from the internet, and then start the Kubernetes control plane. In this case, the whole thing is just a single node. We'll let that continue. What you will need is also kubectl to interact with Kubernetes. That's also already present on my machine here. Container lab, also just copy paste it to install it, and then We have a basic usage scenario topology that we provide, and yeah, you can simply copy this deploy command to roll out the topology. As said, today I'm going to use COS. Therefore, I have another topology that sits here locally. So that's the that's a single node COS with very little configuration in here. No network devices, no nothing. Network interfaces. Sorry. Yeah. So that COS instance is also already deployed, Docker PS. So we have here COS instance already running. So the next thing that we really need to do is install Cert Manager, because we need to have certificates between our API extension API server and the main Kubernetes API server and so on. These will be auto-generated in the background by Cert Manager. So yeah, we rely on that. So that's to be installed. That's applying it, and that's waiting for the Cert Manager to be up and running. Because if it's not up and running, it's using a webhook, we will not get certificates for our SDCIO installation. So we have to wait for that. So that deployment is up and running. So now we install SDC, right? It's this command. And it'll install a lot of like a new namespace, custom resources, deployment, cluster roles, secrets, and all the stuff necessary to bring SDC service alive. To see if the service is up and running. So I said it's extending the Kubernetes API server. What we can do is take a look at the API service API registration. And usually when doing this initially, you will see the availability of this v1 alpha 1 config service being not ready. That's why, because it needs to pull the config server image from the internet and start it and so on. So that might take a bit. But now you see the API resources are already available. And then yeah, we start with the basic usage scenario. For that, I have my own script here now because it's tailored to like this. This is tailored to SL Linux, as you see, like with the connection profile, sync profile, and the SRL secret, and so on. So we'll be using the Arista specifics now. So first of all, we're applying the schema, right? So now you can see kubectl get schemas, and you'll see we've registered that schema. We can also take a look at the file that we've applied. The schema definition with two repositories. First of all, the Arista network YANG, and then also the reference to the IETF models as described in the last meeting, and the whole definition of the schema basically. So the status.
Sorry, can I ask a question here?
Sure, sure.
Marcus, can you scroll up a little bit? No, I think.
You want to see the schema?
Yeah, the schema, correct. Yeah, here. So I see an includes and exclude. I believe this is to like basically like ignore, or exclude is to ignore all the containers that been listed here.
Yeah, yeah.
Okay, and then includes is basically to include another Yang model.
So what you have is you have the main model. That's what's referenced here on the models. That might, as in this case, come from multiple directories, and then you have the includes. In this case, the IETF include that do not define main entries of the model, but rather define types as what does an IP address look like, and so on. And these are just includes that are then sourced from the main model, if that makes sense.
Okay, got it.
Yeah.
Prasad, one of the important things that you should be aware, right? In the beginning, we only had one entry in the from a repo. You see right now, if you go back to the CR, we added the ability to add multiple repositories. So here you see, so there is actually two repositories. So there is an include.
Okay.
So the reason we did that is because some vendors, they when they submit to Git, right, they do everything in one Git repo, but some don't include the references to, let's say, in this case, IETF or something like that, right? So there is some pieces that were not included into it. So in other words, you have the ability to add repositories to augment, and it's typically used for includes. Plus, we also use it for deviation. So if you look a bit further down, right, I think there's also, you can use deviations to, if you see issues with the Yang model, you can actually write patches. So we use it basically to, in other words, this whole CR is a container that will be transacted upon or acted upon together to the schema server. And in the beginning, we had only one entry, but that caused a number of issues. So we changed that to have multiple of these entries so that you can leverage data from various repositories as a collection, right?
So you just basically made this CR a little bit more flexible to add and or include and exclude from many Yang's model.
Yeah.
Yeah. So for example,
multiple repos. Yeah. So Arista in this case doesn't provide the IETF models, right? So yeah, we needed to point to a separate additional Git repository where you'd be able to grab hold of the IETF models.
Okay. Thanks.
Yeah. Wim, you try to say something still?
No, go ahead.
You're fine. Okay. So now you see it took a bit of time to download the model and register it in the schema server. But you see here the ready flag is true. So this this Yang schema is now registered in the schema server and ready for data server to be consumed and utilized. So next thing is to apply the connection profile, the sync profile, the secret, and the discovery rule. So they're all applied now. If we want to take a look at them, so sync profile is using GNMI with encoding JSON IETF, and we're syncing the whole tree from the root on with an interval of 30 seconds. The connection profile, which is used to push configuration, right? So sync is for the read operation basically, and the connection profile is the write operation when we want to push configuration to the device. And that's also using GNMI with JSON IETF encoding that specific port, and it's insecure in this case. What else did we deploy? The EOS secret is just username, password, admin in this case. And then we have the discovery, the discovery rule who ties all the connection profiles and secrets and so on together. In this case, it's a static discovery that's happening. So specifically for this IP address, for that host name. And then you see here the references to the connection and sync profile. And in addition to that, we have the target template that defines some labels. What's happening here is that the target, when it's discovered and created as a CRD in the Kubernetes API, these labels will be applied to it. So we will see on the target these two labels in the end, or we should see them. So let's see if the target got created, right? So this is the result of the discovery rule being there. We see that the COS1 is the device is, or the target is ready, and yeah, can be used.
There is a handy command if you do kubectl get SDC.
Yeah, but it doesn't show headers for the things, so it's not in all cases useful. Specifically here, right?
Okay, I can fix that. I know what it is.
So, and this one, it's like,
yeah, I can fix it. This is the API server. Yeah, okay.
Yeah.
I'll fix it.
So yeah, that's meant to be an overview of all the CRDs that SDC delivers, right? And you will see all of that displayed here. So yeah, we have a target now, right? So let's see if we can retrieve the running configuration from that Arista device, right? So that's kubectl get running configs config sdcio .def, and then we want to have the running configuration of COS1 device in YAML format. And this is it, right? So what happened in the background, data server initialized this sync connection and started to sync in a 30-second interval, and allows you now to query the running configuration via the Kubernetes API. So yeah, that's basically in line with the I don't know. Well, connect to the device and take a look at the running configuration, and we see that the host name is my COS1 device, which means I haven't cleaned up after myself. There should be COS1, but when I ran this earlier, so let's randomly change it. So what we now want to do is add a snippet for this of this configuration, right? So let's once again look at it. You have this configuration that has a name itself, that configuration intent, and it carries the labels target name, so a config sdco dev target name, which points to the target, so where to apply this configuration intent. And then we have the spec with a priority and the config that is meant to sit under /system, so not the root path in this case, and the value for it should be config hostname and then this value, right? So let's go and apply this. And we can take a look at the config intent. It's been shown up with its name, and its state is false. So it failed to apply this configuration. So if we now take a closer look at the resource, you will see it in YAML format again. You will see like the whole definition of the resource with its configuration and so on. And in the status, you will see what happened in the background in data server and so on. In this case, you see that the set intent failed, and hostnai is not a container under config. And this, you see, it's a typo I did intentionally. This does not match the YANG schema in the background. And this is an error message that did not came from the device, but from our schema validation within data server. So data server took a look at the schema, figured out there is a container called config, but in that container, it's unable to find the definition of the entry hostnai. So it's reporting that and not trying to even bother the device with this false snippet of configuration. So let's adjust that. And change it to host name and reapply it. So it's configured, so the value is being changed. And now it says ready true, reason ready. So that means that this configuration that we've given it here is now deployed on the device. Yeah, you'll see that here in the condition now. It's reason ready, status true. That means everything's fine. So let's go and double check that on the box. And we'll see that the hostname configuration has changed. And that's, of course, also reflected in the running configuration that we are able to retrieve. We should, of course, try and get the whole thing. Right, so hostname, myce blah os. So yeah, also this change is available in running configuration in Kubernetes. I've prepared another command where you'll see it a bit more in the structure. We'll see, it's there. Let's go and create another configuration that's a bit more, I'm not sure why it's showing up like that, which is a bit more extensive now. It's yeah, defining an interface with a description, with the type and a MAC address. So let's go and apply that. That one made it through to the device, so no typo in the configuration. Let's double check on the device, and you'll see we have an interface Ethernet 1 with the description and the MAC address. The other stuff in here is default values. So yeah, that's why it doesn't show up. So let's now go and change the MAC address on the device. So that's Ethernet 1 MAC address. MAC address. So now where is it? Now the MAC address of interface Ethernet 1 is changed manually on the box. And what will happen in the background is that the syncing still takes place in the 30-second interval, and it'll detect that this value of MAC address that it expected to be AABBCC is changed from the expected value. And what we do then is data server will go and revert that manual change that we did on the box. The plan is to also allow these sort of changes, but yeah, right now the standard mode is to revert.
Just a quick question. So this is classed as a deviation, and what type of deviation do you call this? Because if I remember from last time, you had different namings for different types of deviations.
Wim, are you aware of the names?
I can chime in. So we have three types. So this is what we call. So yeah. So before I go, right, what is important to understand the way config server works, but it's hard to let's say explain, right? So we have an ability to merge. So in other words, see, we have all these config snippets, right? So that's what you see here, right? So in other words, you could have two intents that have conflicting information, right?
Yep.
So in other words, one says MAC A and the other MAC B, okay? So we have a mechanism inside of the data server to basically resolve that, right? So, and one of the things is the priority. So through the priority, if you have a lower priority, you will not win, right? So in other words, the one with the highest priority wins, right? And so that's the parameter that we take. And we can do the merge on a per leaf basis. Okay, so that's the first important thing to understand. If there is two intents with the same priority, the first one that got applied wins. Okay, so that's how we do deterministic behavior. So why do I say that? Is that there is basically three types of deviations. One is a deviation that is actually related to the highest priority intent, right? And that's actually what you see here, which is what we call, so basically an intent deviation, right? Which is, so basically the deviation based on the intent that got prioritized. And so this we revert at the moment automatically. We will add a knob to not do that, right? But so that is,
Does that mean, so you assign a particular priority for the config coming from the device, which is lower than like a low priority, right? That's lower than what the intent is.
No. So this is basically, so when you apply intents, you also give a priority. I think, Marcus, can you show again in your config snippets? So you as a user or as a client, you can determine the priority. So what I was trying to say is that let's assume you have two intents that have conflicting information. So the parameter that wins is the priority, right? So if you have two intents, one with 10 and one with 20, right?
Yeah.
The one with, I think it's lowest. So we start with lowest, I think, right? Instead of highest. But so the one with the lowest number in priority wins. So if you would have two intents with the same content and conflicting content, and parameter A for priority 10 was different than priority 20 for intent 2, then the one with priority 10 will win. Okay? So if you change that parameter, the deviation, so all the deviations are reported equally, but the data server calculates or can calculate based on the intents and its priorities, right? And its order or its time when it got applied. It knows the one that should be active, right?
Yeah.
So in other words, the three types of deviations that we support is a deviation of the highest priority, right? The second deviation that we support is a deviation from an intent that got overruled by an intent of a higher priority, right? So in other words, if you go back to the example, I have intent 1 with priority 10 and the other one intent 2 with priority 20, and they have a conflicting parameter, right? So parameter A wins from intent 1 and 2 with a conflicting value. So we report that deviation to that intent, but there is a type that what we call overruled, meaning the intent will have that deviation in it and it will report it, but it doesn't do anything because we know administratively someone has configured a system that another intent overruled it.
Yeah.
You see?
Okay. Yeah.
And then there is a third type, which is what we call unmanaged deviation, so which you can also see right now. So all the config for which you do not have a configuration, we report as unmanaged config. So there is an unmanaged config CRD. So if you do kubectl get unmanaged for that device, you see all the deviations that are for which we do not have an intent. And that's the 1090. So we report path and then value. So you see, so you have a XPath and all the values.
So that's basically stuff that sits there in the running configuration, but that we do not have an intent for. So this can be considered brownfield config, right?
Okay. Yeah, that makes sense. Yeah.
So these are the three types that we have.
Now I got the question. Suppose we only have one intent, and then I'm doing some troubleshooting, and then I need to change the MAC, right? So and then it works in the network. So what will happen? By right, this MAC will be rewritten by the intent engine, right, or the configuration engine.
Yes, at the moment we revert, so we'll add a knob to not do that and only report, right? And then you will see it. It's part of the config of the CRD of the CR. You will see it in the status that it's that there's a deviation. So that is very easy to do. Basically, it's like
I review from the last video. I think you can just compare and then you just like flag it, and then this is going to be like a approved misalignment or okay. And then you can also take that configuration that you discovered from the NE itself, the new configuration, to be expected intent also, right?
Yeah, so this is one of the things that we wanted to discuss is how you guys want to deal with replace and running config and avoiding the deviation. So one option is, for example, the example you just had right now is because you get a deviation. You can do a watch on deviation on that CR. You can see deviations, and then you can update your intent with that value, right? So you could write a program to say, hey, is that intent valid? Update the CR, and then it will remove the deviation. So we will, so what we will probably do in SDC is basically give you the deviation. So we'll report it in the status, but the automatic action right now is within SDC. So you could write a controller that basically does that revert or basically accepts it and updates its intent and stuff like that. I mean, we can do a prototype to show how that would work. But because typically some of these deviations you want to accept, some not, so that's up to you, right?
Yeah.
How you deal with that?
I think, I don't know how it is with SR Linux, but I have a bit more experience with Arista EOS. And I see that the config that you get via GNMI is way more of a boast than what you would get on the CLI, on the device itself. And actually, there's a lot of config in there which you wouldn't provide an intent for, I don't think. So even if you have a full coverage of your intended config for a device, I think you're still going to have a lot of unhandled deviations, which is probably fine because it's just stuff you get it back in the config from the box, but you don't care about it being changed, and you actually don't want an intent for it because you're never going to change it. So I can imagine that you would always have unhandled deviations for many devices, at least with Arista. I'm not sure how it is with SR Linux.
Same. I mean, if you take as a Linux, you get like 7. I think in my setup, I get 700 and something deviations. If you don't do anything.
Yeah, which I think is not really an issue, right? As long as there's
correct.
A way to delineate between unhandled deviations, which you might not care about, and ones that you do care about, which are changes on the box, which you have intent for and you either want to overwrite or flag them as okay. We manage them for now, but yeah, so seems like a good logic to me how it is at the moment, at least.
The one thing that we wanted to discuss is basically your replace operation as well as the. But so
just like quickly finish it.
Let's finish it and then we will set up
2-3 more things, right?
Correct. Yeah.
So don't know if you guys have seen it. The configuration has been reverted, right? So the deviation has been rolled back. Realigned. Next thing we can do is to delete an intent, right? So we have the COS Ethernet 1 intent, right? So I've deleted that now from the Kubernetes API, and doesn't appear in the list anymore. And we will also have removed the interface configuration from the device itself. So before we've had description and MAC address and so on, and now it's just the Ethernet 1 outer definition still there. What we also have is configuration sets, like the means of of writing a template, basically, that is then applied to multiple devices at once. If you remember, that was this part here, where via config set you would reference targets by a label selector, and the the CRD reconciler would, for all the targets that the label selector would match, create configs, throw them in, and the config reconciler would take those also and push them to the target. And that's what we have here. It's like from a bottom part here, it's the same as a regular configuration. You define the priority, you define the path and the value, value that sits under that path in the YANG schema in the configuration. And then as part of the spec, you define a target selector with match labels, which means that these two labels must be attached to the target. And if they are, this configuration, a configuration resource is created per target out of this configuration set. So let's apply this thing. Config set Ethernet 2. So we see it's there. It does say 0 targets. That's an issue. I think Wim, you need to take a look at that because it was created.
I need to fix. Okay.
There's a bug here. it should say that there was 1 target for it. Yeah, bear with us. We'll fix that. So yeah, based on that configuration set, configuration is being created, as you see here. It carries the name of the config set with the target name as an addition. And if we now take a look at the box, we see that on that box, on that COS1, we have created Ethernet 2 interface with description and MAC address as we've defined here, right? Description, and here is the MAC address. And then my last point was the unmanaged configuration, but yeah, we've already taken a look at that now with the head defined. So you'll see like the CR content itself, some administrative values in here, and then under status deviations, you see the unhandled deviations with the desired value of nil, because we do not expect anything, because we do not have an intent for this path, and we just report that. And that's basically it.
Yeah, thanks. It looks really nice. I just had a question, again, back on the deviations. So when there is a deviation that is overwritten by the intent, is there some way to see that happened? Does that get listed in the deviations like a historical deviation, or is it removed from there once it's
I think there is an event. There is an event that we put in the Kubernetes API. So check it, Marcus, kubectl events on the config CR. Oh, you have to go to the CR, I think. The kubectl describe CR. I think I put an event, but I'm not 100% sure. I need to double check. If I'm not, I will do it. And then the CR.
CR that we've deleted.
Ah, shit. Yeah. I'll have a look then, right? But yeah, so normally there should be an event that you sent, right? So in other words, you know that reversion happened. But I will add a knob, right? So I'm, by the way, doing reversion or not reversion. Do you think this is a global thing or not?
I would probably think of it more on a per device basis, because I would imagine, yeah, I mean, I'm thinking operationally, you might want to basically flag a device, put it in maintenance mode or whatever you want to call it, and then you would be able to apply configuration changes to it and not have them overwritten, basically like a troubleshooting window.
Yeah, okay, yeah. So in other words, if you add a label to a target, right? So then based on that label, we will revert or not, right?
Yeah,
okay.
Yeah. I think that would make sense. Yeah. I mean, I'm very pro kind of overwriting the config if it's changed. I don't like to see drift if possible, but I understand that operations guys will want to have the ability to be able to do stuff on the box, right? And not have it overwritten. Sure. Yeah.
Because the other option that we can do is by default just report, and then you're up to writing a control. Because at the moment I do it all in one, right? So I basically update the status, and if I see it's the highest priority, it's really a deviation that was not overruled, I basically revert, right? So I do it all in one go in a controller. Okay. Now I could basically say that controller only updates the status, and you write another controller that takes care of the reversion, right?
Yeah. I think
then you have the flexibility.
Yeah, true. Yeah, I guess different organizations might look at it differently, or different teams might look at it differently.
Yeah, correct.
Yeah.
And we can make an option. We can make an option in the configuration of the config server that you want that reversion or not based on that label of a target, right? So, and then you can decide whether you include it in your deployment or not. So then you have the flexibility, right? You get it out of the box if you add a certain parameter to the config.
Yeah, that makes sense.
Okay. Yeah.
Good question again. So, I assume this device communicator, the component that talking to the NE can be scaled, right?
Yeah. So at the moment, what we do right now is it's all packaged in one, right? But we have a plan to make it distributed, right? So it's to distribute that across multiple entities. So if you look back to the picture here, see all of these, we draw it here as bubbles, and they are actually like that implemented.
Okay.
But right now, so in other words, you could deploy them all as dedicated pods. So each of these things could be its own pod. But right now, we package it all in the same pod. There is 2 containers, but they are packaged all together, which means that you don't really have scale out, right? But if we
I think that is possible, right? Because you are putting it on the container. Let's say if I want to scale the data server to be multiple pods, I think that is still possible, right? So we can handle a lot of alignment at the same time, right?
We have to do a little bit of work to basically assign a target to a data server, right? So there is a bit of work to be done because you want to have consistency, like the southbound from the data server, there is a GNMI connection which is always on, right? Otherwise, so from that point of view, we assign a target to a data server.
It must match that, each and every config that is meant for this target, it goes to the data server that's taking care of that target, right?
Yeah. So there's a bit of work there that we need to do, but it's not. Yeah, I mean, I
think it's already foreseen, but we haven't implemented that lookup and also assignment code. It's just taking that that single entry out of that list, and that's it.
It's doable though.
Yeah, we can. It's not so difficult to do. I think it's just a matter of a bit of time and priority. I
think the architecture already support that. I can see this.
And we could also go for a design where it's stateless, but that's a bit more work, right? Because see, the cache, so the data, if you look to where the running config and the intents are stored is in the cache that you see on the right-hand side, right? So in other words, but then every transaction that you do to the device or every configuration, you basically go via a dedicated data server, which avoids the assignment. So there is basically two approaches. It's a bit more work because with the moment we have this assignment, but you could do a full stateless architecture as well, which means, that means that maybe that's not correct.
For syncing, you would need.
Yeah, for syncing, yeah, for sure. Syncing is one, right? But then, but we don't do that all the time, right? So it basically, so there is still a few options that we can explore, right? But right now, we are focused on, let's say, bring transactionality to the system, right? So that's the first thing that we are going to tackle, and then we can look at this.
Interesting.
Yeah. Yeah. So maybe if there is no further question, maybe on the last 5 minutes, if I may, Marcus.
Sure.
Can I ask suggest a little? Returning back to the configs snippet prioritization.
Yes.
It's also good to have, for example, for the shared configs like MTU for the interfaces, or something like have a shared create or something like. For example, you have one snippet for MTU, setting the MTU for the transit interface, and for the for example, VLAN on that interface, another snippet to set another MTU, or maybe a logical MTU, or maybe overwriting that MTU. And if we can get the, for example, shared create functions that all interact on the increment count of how much snippets use this parameter, and we move it only when we delete, for example, shared create. We just subtract this parameter and delete configuration just when the last config snippet is removed. So we can create, interact, or kind of add one plus for the links, or for the maybe, for example, I create the interface, I create the MTU for this snippet, and I have another snippet that creates the same MTU on the same interface, for example, for some unknown reason. But I can just say that increment link counts on this MTU is 2, and when we delete service, for example, first one config snippet, we just subtract -1 from this shared create links number, or resources, number of resources use this certain line.
All right. What does the amount of the links? What does the parameters?
I just in the parameters, just saying that how reference count number. For we can just meet first service and create the reference count number 1. Create second, make a second snippet, and the reference count number started to be 2. And if you remove first one, it will still 1, but it's the MTU on interface stays the rest, stays on the configuration because of somebody used it.
Yeah, so that's what we do. So let's say if you have priority 1, you say 9,000. Second intent with a lower priority says 5,000, and then nothing, right? So what will happen is first, when both intents are there, 9,000 wins, right? So that's the parameter, and the reference count we do under the hood, but we don't expose, but we have that under the hood, right? If you delete the intent with the 9,000, the 5,000 will be applied. That's how it will be, right? And then of course reference count is 1, right? So we do that. That's what we do. And then if you delete the last one, or you add the other one again, then you get the revert operation. But if you delete it, the MTU is deleted basically.
Okay.
Right?
Okay, good.
We do that like that. We could actually show it. Yeah.
Yeah, because of it's interesting to get it kind of exposed, because of you can immediately understand why it's not deleted.
Yes, we do. You do. Yeah, what we do basically is we. Yeah, so this is going back, and that's also we have to do a little bit of work on that, right? Is that we can say which parameters, which intent was the one that is actually driving it, right? So every parameter we can say from which intent it was derived.
Mm-hmm.
So you see the highest priority, you don't see the lower priorities, if you will, right?
Okay. Yeah.
So we have to do also a little bit of work there to make it better exposed, right? In the deviations, you have somehow a hint, but it's not maybe explicit, right? But if you look under the hood, what the data server does is exactly what you said, right? That's how it works.
Mm-hmm. Okay.
And it's per leaf. So in other words, it's per parameter in the config.
Per XPath.
Per XPath, correct, yeah.
Okay, good.
Yeah, so maybe we are running out of time. Is it okay that we do a follow-up session, but more focused on architecture discussion next week, Thursday, or is that okay with you?
It's good for me, yeah.
Yeah, so it's more on the transaction and the replace, so maybe it's good. Maybe otherwise, because I'm expecting it not to be 5 minutes.
Yeah, for me it's good, yeah.
Yeah, I'll set up another call, yeah, next week, same time.
Sounds good.
Yeah, so Marcus is basically preparing your example, I think, beginning.
I'll need to
Yeah,
drop, guys. I've got another call.
Yeah, okay,
but,
thanks, Dan.
yeah, thanks a lot, guys. Yeah, cheers. Bye.
Yeah, Evgeny, I'm not sure if you followed my typing.
Not really, just was
Okay.
the section.
So what we can do is you see now host name device dash 100 is applied, right? That's coming from kubectl get configs. That's coming from this resource. Kubectl add apply config host name. So that one has priority 100. Kubectl get configs.
Maybe I also have to expose the priority here, maybe in the output, if that's handy.
That doesn't help much, right? Because you do not know which paths.
No, but at least you know the priority from the config
Yeah.
that was applied. I mean, it's, yeah.
So yeah, you see priority here for the dash 100 is 100, and for the other one priority is 10, right? What we have is the lower the number, the higher the priority, right? So 10 overrules 100. And if we now, yeah, you see, like both of the intents have been created, both are ready and accepted, and that means although the 100 is not applied to the device, it is accepted as configuration that's valid. But at the same time, this one is the higher priority. You do not really see that other than connecting to the device.
Or can you have a look at the deviation at 100? You should have a deviation.
Yeah, let's take a look at this one first. Configure terminal, show running. So you see host name. Right. So host name is the one from the dash from the priority 10 right now, right? So if we now go exit and we delete.
No, does do a describe of deviation first, Marcus, for the second intent? Conflict. Second one. 100.
No.
Status. Okay, we need to check that. Fine. Oh, YAML. No.
So if we now go and delete the one that has the highest priority right now, which is COS host name, that's priority 10, then we're left with the
100.
host name 100, and that has become active now. So CLab COS admin. Yeah, you already see that here in the prompt, right? So we keep the list of the values, and although you're deleting the highest priority, the active priority value, as soon as you delete that, the next highest precedence value becomes active instantly.
Yeah, good to know. And for me, it's to show at least how much or what the certain configs snippet are connected is really interesting, because of if you, for example, go to the brownfield and try to change or trying to understand how much services depend on this certain line or certain XPath, it will be good to know who is responsible and what will be done. What will be breaking if I change something or delete it.
Mm-hmm. Yeah.
And also, if you want to take something out of service or whatever, you just
You can
just add an intent that changes the admin state to disable.
In this case, you can reverse compile what services are on this device.
Yes. Yeah. Which parameter came from which service, basically. Yeah. Correct.
Yeah.
Yep.
But also, what you didn't show, but what will also work is like if 100, if 1 was there, you would delete it 100, and then deleted 1, then the parameter was gone, right? Or would be reverted back to the default on the device.
No, we've seen deletion.
Yeah.
So
but I mean, if you delete the lower priority, nothing will happen, is what I said.
Yeah.
And then if you delete the highest, so there is another, let's say, scenario. But yeah, I mean, yeah.
Yeah, but prioritizations is handy here.
Yeah, correct. Yeah. Because one of the things we'll discuss that next time, right, is the way to look at running config, or let's say backup and restore, is use running config as a way to do it, but with a very low priority, right? And so that's one of the things that we will discuss as a way to, let's say, restore to a known good state, and also as a way to get, to treat it as an intent. But we'll discuss that in more detail next week when we go through that.
Okay, thank you.
All right, thanks, Marcus. Appreciate, and we'll share the recording and once available. And thank you all. Talk to you next week.
Thanks. Bye.